6.2 is the main thing is your central limit theorem. Sampling distribution is just a small introduction of how we convert to a central limit theorem. So the beginning of 6.2 is a little bit confusing in terms of the concept behind the practical item. So bear with me here. As you will see that 6.1 and 6.2 are very similar. It's just that you have to do a small adjustment, and I will tell you what that adjustment is later. So in real life situation, most statistical study, we don't have the population, right? We don't have the population data for us to state. So most of the study that we do, we have to do some sample. So just imagine that this is the population that we have, but there's no way to access the whole population. What can we do? Well, we can take a small sample of the same population. It's just that we have a small sample here and there, right? You know, if I ask you, if I want to know what is the population will vote on the next election, I cannot gather everyone. So I have to go to different parishes and get the sample, right? I gather the sample, and again, each of this sample, which is the X bar, is the sample mean. So this thing here, this is what we do, or as we gather each sample, the mean will be different because not all data are the same, right? Because in different region, different people, different age group, they will have different item, different mean or different average, right? So look at this thing here, is this idea of go into your population and get a small group of sample is just basically tell you that this is a sampling distribution, okay? And it's uniquely that we do this thing here. We take each sample of the same population, we take each sample, and when we put them all together, no matter how the sample is, when we put it together, when we calculate it, it's look like that if we get more sample, if we gather a lot of sample, then your data eventually become a normal distribution, become a bell-shaped curve, okay? So that's the idea here is we go individual sample, we take, and when we calculate them, it's turned out that all of the sample, when we put them together, if we gather more and more data, more and more sample, your information will tentatively come out to be a normal distribution. So this is where the central limit theorem come in, right? The central limit theorem come in is if X, meaning you go and collect your data can be any distribution with the mean of the population mean and the population standard deviation, right? So your X can have any, skew to the left, skew to the right, or whatever the distribution they want it to be. And if we collect a lot of that data, which is the sample size, meaning if we have a large sample size, your data eventually approach the normal distribution. Okay, so again, this is the item that they tell you that if we collect the N, which is again, basically they tell you that you gather many sample, and the more sample you gather, the data will eventually become a normal distributed, which is a bell-shaped curve. Okay, and if you remember in chapter 3, I told you guys that if I flip the coin, right? If I flip the coin and you say, well, if you flip the coin, you have 50-50, right? And I told you, well, does that mean, do you guarantee that if I flip 10 times, I have 5 head and 5 tail? As you say, well, no, I can't. You just know that every time you flip, you have 50-50, which is, I told you that if we do it a lot, it tends to come out to be 50-50, meaning if we flip 1,000,000 times, then yes, eventually maybe that when you get 500,000 head and 500,000 tail, which is the law of large number. So based on that law of large number, they come out to this central limit theorem. Basically tell you that if you collect a lot of sample, then your data will eventually become a normally distributed. Okay, so how large is large, right? How large is this N have to be, right? We cannot go out there and collect 1 million data, right? How large is large, and how to determine if the sample is able to, or can we use a normally distribution to approximate them, right? So this is the two idea is for this author, the number is the N, the sample have to be bigger than 30. Some other book, they have N is greater than or equal to 30, but this author, he basically tell you that if the N, if the sample is bigger than 30, you have a green light to use the normal distribution. So very much, if your N is bigger than 30, yes, you can use the normal distribution to approximate item. It's appropriate to use it. The other thing is, if your population is normal, if we know that the population is normal, then it doesn't matter how many samples we have, we can use it. Okay, so if the population is normal, doesn't matter what the sample size, you can select 10 of them, you're good to go because your population is already bell-shaped curve. Okay, so those are the two options. Is the population either be a bell-shaped curve, we can use the normal distribution. If the data, if we don't know if it's normal, then your sample size have to be bigger than 30. Okay, so let's take a look at this example here, which is, again, once we do the example, you will see that the theory behind it is a little bit difficult. I will go back to this. So let's take a look at this problem here. They ask you, can we use the normal distribution, or is it appropriate to use it here? So let's say a sample size of 15 will be drawn from a population with the mean of 125 and the standard deviation of 28. Based on this information, is it appropriate to use the normal distribution to find the probability of the mean? So looking at this thing here, can we use the normal distribution? Hopefully you say no. Why? Because the sample size is not bigger than 30, right? We don't know what the population is. We don't know what the population is. We know that since we don't know what the population, the sample size have to be 30 or bigger than 30. It has to be 31 or more. In this case, the sample size is not 30 or it's not bigger than 30, so we cannot use it. It's not appropriate to use the normal distribution because we don't know what kind of data this is. We don't know if they are a bell-shaped curve or skewed to the left or skewed to the right, right? So looking at this thing here, is it appropriate to find the probability that X is less than 120? No, because same as the reason on the part A, we don't know if it's a normal distribution, so we cannot find any probability. Remember, your normal distribution is the only time we can use the normal distribution is when it's a bell-shaped curve. If it's not a bell-shaped curve, then we cannot use it. Okay, and take a look at this thing here, which is if you read number two tell you that a sample size 5 will be drawn from a normal population with the mean of 60 and the standard deviation of 12. Same 3 question they ask you is it appropriate to use the normal distribution to find the mean? Which is, in this case, you probably say, oh, Mr. Tran, size is 5, very small, so we cannot. But ladies and gentlemen, we could. We could. Why? Because they state right here, they state that the population is normal. So the population is normal, doesn't matter what the size is. We don't care if the size is 2 or 30 or whatever. As long as one of them, which is, if we know that the population is the bell-shaped curve, then doesn't matter what the size we'll be able to use it. Okay, so that's the idea here is how do we determine, do we have a green light to use this normal distribution? Your 2 green light is if you see that they say the population is normally or approximately normal, then we can do it. Doesn't matter what the size. Or the other one is the sample size have to be bigger than 30. It have to be more than 30. In this case, there's no green light. This one here, there is because of this normal population. We will go back to B and C, but again, it's a question on how to determine when we can use and when we cannot use it. So let's go back to this slides here, ladies and gentlemen. So one thing is, remember I told you in 6.1, that in order for you to do any calculation, there are two things you need, which is you need the mean and you need the standard deviation, right? So looking at this thing here, if you look at this thing here, this is the definition of a central limit theorem is this. If you have the mean number if you have a large sample, meaning how large? If you have the sample size is bigger than 30, then this is what you will say. You will say is the mean is the sample mean is the same as the population mean. Okay, so whatever the population mean is, your sample mean will be equal to that. It will not change. Okay, this is basically tell you the sample mean, this is the population mean. And the standard deviation for the sample, this is basically all you do in 6.2 is, in order for you to perform your calculation, we have to do the adjustment to the population standard deviation. The difference between 6.2 and 6.1 is 6.2, we deal with a sample. And because we do with a sample, we have to convert the population to become a sample population. So how do we convert the sample population? Well, all you need to do is take the population standard deviation, sample population. How can you convert the standard deviation, the population standard deviation, to become a sample standard deviation, I should say? And to do that, this is all they tell you to do is take the population standard deviation divided by square root of n. Okay, so whatever your sample size is, you take a square root of that. Okay, so this we'll sometimes call a standard error of the mean, because we try to do an adjustment. We try to adjust the population standard deviation to become a sample standard deviation. That's why they might have some error. Okay, and again, you will see in chapter 7, you have the margin of error. But again, for now, we need to, in order for us to calculate calculate 6.2, we need to do adjustment. So let's take a look at this thing here, which is, let's take a look at your problem. So this is your 6.2 problem. How do you determine, right? Right now, you probably say, okay, all of this thing are the same. So how do I determine if I'm in 6.1, if I were to take this test, how would I determine if I'm in 6.1 or I'm in 6.2, right? So first of all, in 6.1, they won't give you this. They won't give you a sample size. So if they say a sample size, if you are dealing with a sample, you are in 6.2. If you are dealt with a sample, if they give you a sample, you are in 6.2. So look at this in here. They say a sample size of 126 will be drawn from a population with the mean of 26 and the standard deviation of 3. So we know we have a mean and we have a standard deviation, which is, those are the two things we need, right? So looking at this thing here, can we use the normal distribution to find the probability between these two values? Which is, hopefully you say yes. Why yes? Because the sample size is bigger than 30, right? The sample size is 126, which is way bigger than 30. We have a green light, go ahead and calculate. So how do we calculate? This is what we need, which is, reminder, you need the mean. The mean is the same as the previous mean, which is, again, the mean, the sample mean is equal to population mean, which is whatever the mean they give you, that's the mean we're going to use. Now, the only thing is, because we dealt with a sample, we have to make a small adjustment to our sample standard deviation. And that small adjustment is the only thing different between 6.1 and 6.2, ladies and gentlemen. What adjustment we need to do? We need to take the standard deviation divided by a square root of n, which is, if you take the standard deviation, which is 3, divided by square root of n, which is square root of 126, this is what you guys will have. Let me share you my other screen. Give me 1 second here. So looking at this thing here, which is, anybody have TI-83 in this class? Anybody have TI-83? So if I use the
yes,
TI-83,
I do.
okay. Let me do the TI-83, because 84. If you have 84, it's gonna be it's easier. But let me do the 83 because some of you guys have the 83. So again, 84 is fine. So looking at this thing here, so once we do this small adjustment, right? So all of you guys see the calculator on my screen. So once we do this adjustment, this is what we have is, because they ask you find a probability. Remember in 6.1, to find a probability, we need to find a probability, we need to know that we have to use the normal CDF, right? So again, looking at this thing here, we know that this is what we need to do, is we need to find a probability between these two regions, and to find a probability between these two regions, we need the two endpoints. And again, this is what we have, which is, if you have your calculator, and like I mentioned, this is all we need to do is tell your calculator to calculate for you. You don't have to do it by hand. That's why. So if you hit second VARS, which is second vol, we're choosing the same thing, which is the normal CDF. And now, what is my endpoint? My endpoint is 25, comma, 27, comma, my mean, which is 26, comma. And ladies and gentlemen, this is, for me, I type it as it is. I just go and type 3 divided by square root. And to get the square root, you hit second square root, which is 3 divided by square root of 126. For me, I just type it this way, and I just close the parenthesis and press enter. So for me, I just type this way. Instead of type in 0.26726.124, you can type that thing in. But if you use in the decimal place, ladies and gentlemen, make sure to keep at least 7 or 6 decimal place. If you type in 25, comma, 27, comma, 26, comma, 0.26. Let's say if you just say 0.26, everybody see that the answer, it will be a little bit off because you round up. Because instead of, you probably put 0.27 if you do 2 places, and you will round up and you say 0.99999. But again, so try to not round up. If you use the decimal, give them at least 6 or 7 decimal places. Everybody see what I'm talking about here. Instead of, if you don't want to type it this way, for me, I type it this way. I type 3 divided by a square root of 126. If you don't type it that way and you want to use the decimal place, at least give them 6 decimal place or 7, or the more decimal place, the better, because you only round at the final answer. Whoever took the midterm, you already saw that if you round in the process, you will get the wrong answer, right? Your answer will be a little bit bigger or a little bit smaller than the actual answer, okay? So again, but first of all, hopefully you guys see, hopefully you guys see that the equipment, the feature that we're using in 6.2 is the same feature that we're using in 6.1. The only thing different is we need to, because we dealt with a sample, because they give us some sample, we dealt with a sample, we have to adjust Again, this is your population mean, this is your population standard deviation. We have to adjust the same standard deviation, the population standard deviation, to become a sample standard deviation. And that adjustment is a square root of n, right? Take the standard deviation, divide by square root of n. And again, if you look at B asks you the same thing as before, right? B asks you the same thing that I asked you earlier, which is find the 55 percentile of this thing. So how do we find the 15 percentile? Well, 55 percentile tell you that we have to use the inverse norm. Right? Inverse norm, which is to do this thing here, we have to do inverse norm 0.55, which is that is the area to the left, comma 26, which is your mean, and your standard deviation is the adjust standard deviation, which is the sample standard deviation, which is 3 divided by square root of 126. And if you do that, as you can see, there are 26.03, right? Which is, again, this is the sample mean, the, you know, if the 55 percentile of this mean, right? So again, first of all, question on how to utilize your calculator. Again, if you have the TI-84, when the window prompt come up under the standard deviation, you just type 3. Under the standard deviation, you just type 3 divided by a square root of 26, and then you press calculate, and they calculate for you. Okay. If you have manually type in, you have to hit that. And again, to get the square root, you hit second square. Let's go back. Question with this one before we go back to the previous slides. So if we do this thing here, which is, again, let's finish this problem up, right? Let's finish this item here, which is, again, on your homework, they probably ask you this, which is a sample size of 5 will be drawn from a normal population with the mean 60 and the standard deviation of 12. Is this appropriate to use the normal distribution to find the probability? We say yes. Why yes? Because the population is normal. Now the follow-up question is, if it's appropriate, find the probability that is between 50 and 70 and find the 80 percentile, which is, as you can see, is the same as we have before, which is, let's take a look at this thing here. So to do B, we know that we need the mean, which is the mean is 60, and the standard deviation, we know that we have to adjust your standard deviation, and that, ladies and gentlemen, is the only thing new, is we need to find the standard error, which is the same as your sample standard deviation, which is we take the standard deviation, divide by a square root of the sample. So again, for me, this is what I have, which is, again, I know that we're looking for the probability between 50 and 70, which is my endpoint. I know that my endpoint is 50, 70. And then again, what is my mean? My mean is 60, and my standard deviation is 12 divided by a square root of 5. So again, in chapter 6.1, in section 6.1, instead of divide by a sample, because there is no sample, in 6.1, we deal with the population, so there is no sample to divide with. 6.2, that is the only thing new, is we have to divide by a square root of n. And once you have that, this is what we have, which is this thing is equal to 0.9376. And same idea go, which is, again, the 85 percentile, which is 85%, which is the 85% on the left, which is, we know that we need to do the inverse norm, and the inverse norm of 0.85, 60, and 12 divided by square root of 5. So again, question here, before we go to your massive, I'm not scared, try to scare you. We go to our application, which is a realistic example. Question on how to use your calculator, question to how to enter in your calculator here. So let's go back to this thing here. We did this. I got the other one, I forgot. Oh, we didn't do that, sorry. Let's take a look at number 2. Number 2, again, same thing go. If you look at number 2, they say a sample size of 284. So we know that we have a green light, right? Doesn't matter what the population is. My sample size, my N is very big. It's more than 30. I'm good to go. I can use my normal distribution, right? For the population with the mean of 45 and the standard deviation of 7. So everybody see that this is your typical question, and now they ask you to find the probability, and they ask you to find the 75th percentile, which is, as you can see, it's the same question as in 6.1. It's just that now we are dealing with a sample, right? So to do this thing here, which is, again, what is my mean? My mean is 45. And what is my standard deviation, which is, again, I have to adjust my standard deviation, which is I have to take 7 divided by a square root of 284. Okay, so once I have this thing here, I ask myself, which is, again, do you agree that greater than 46, meaning, again, anything to the right hand side of that is greater than 46? Agree? Last time they asked you in between, this time they asked you for the area to the right. And if you remember yesterday, the area to the right, how do we input in our calculator? We use the normal CDF. And again, what is my lowest endpoint? My lowest endpoint from left to right, the smallest number I have is 46. And then I keep on going to positive infinity, which is in this case, some big positive upper limit, which is, again, this one here, I use 10 million. Like I say, a million is good, but 10 million is better. It's not gonna make any difference. As long as you have some humongous number, at least 100,000 or more, okay? And again, my mean is 45, that's my mean, and my standard deviation, because I deal with a sample, and again, you hear me state this all the time, because we deal with a sample, because we deal with a sample, we have to adjust, which is we take the standard deviation, divide by a square root of n. That is your new standard deviation. And once you find this thing here, you just plug into your calculator, which is you will have 0.0080, right? So again, is this unusual? Very unusual, right? It's very unusual to have this item, okay? But again, they don't ask you unusual, they will later. Same thing go with this thing here. To find the 75 percentile, which is the 75%, which is the percentile, is another word for the percentage to the left. Once we have that, we identify that it's an inverse norm. So it's 0.75 comma 45, which is your mean, and your new sample standard deviation, which is square root 7 divided by square root of n. And again, this is what we have, which is question with this thing here. Question with this item that I have in terms of this slides. And ladies and gentlemen, that's all there is in 6.2. The only thing new, right? In a nutshell, the only thing different in 6.2 is, first, we dealt with a sample. Second, because we dealt with a sample, we have to adjust our sample standard deviation to become a sample standard deviation. That's the only new adjustment. The operation, the feature that we're using to calculate is the same, okay? If we were to do it by hand, we do it everything the same. The only thing changing is you plug in the sample standard deviation rather than the population standard deviation. So let me do one more problem, and I think this is your typical homework question. So let's do this problem here. I know I'm running a little bit short on time, but bear with me here. Let's say that this is your homework question or if you're done with your midterm, like I mentioned, you start on your homework and you see this question. So again, looking at this thing here, a SAT score is the name of the problem. The college board report that in a recent years, the mean math SAT score were 514, and the standard deviation were 118. A sample, again, that should give you, ooh, we have a sample. We deal with sample. We are in 6.2, ladies and gentlemen. So a sample of 65, is that bigger than 30? Yes, we can do it, right? So we know that we can do this item here because we have a green light bigger than 30. That's good enough. So now looking at this thing here, they ask you, what is the probability? We know that probability, we need to use the normal CDF. What is the probability? Normal CDF. Find the percentile, inverse norm. What is it unusual for greater than the number, which is, again, this is doesn't have a percentage, so this is normal CDF. Okay, but again, let's take a look at A, which is this thing here, which is, again, in order for you to do A, B, C, D, E, we have to know our mean and we have to know our standard deviation. Everybody agree that this is my mean, 514, and my standard deviation, I have to do that adjustment. I have to take 118 divided by square root of 65. So once I have this thing here, do you agree less than 500, meaning, again, I'm looking for the area to the left of 500. My 500 is this black board right here. That's my boundary, that's my 500. I'm finding the area to the left. And to find the area to the left, I need to put in normal CDF. And because the area to the left, what is my smallest value? My smallest value is some negative, small negative number, which is, in this case, I put a negative 1 million. Like I say, negative 1 million, negative 10 million doesn't make a difference. Negative 1 million go up to 500, which is my endpoint. My mean, which is 514. My standard deviation is 18 divided by square root of 64. Once I have this thing here, I plug in my calculator, and the calculator tell me that is roughly 17%, right? So again, the probability of you go in here and select, right? Based on this 65 people, the probability you go in here and select one of them, the mean is less than, again, the mean is less than 500, meaning, again, is 0.1694, okay? So again, first of all, question on how I have this answer here, or question how to sketch your graph, or how to use your normal CDF. And hopefully you guys see that 6.2 is so close to 6.1. And you will see 6.3 is the same. It's just the normal CDF and the inverse norm, okay? What is the probability that a sample mean score between? Well, between, we know that because it's between, then I need to find the area between. And between is easy because between, whatever the two value is, that's my two endpoint. My lower endpoint and my upper endpoint. My mean, which is 514. And again, the standard deviation is 118 divided by square root of 65. I plug on that, and this is what I have, which is 0.6490. Okay. And again, lastly, in terms of this thing here, find the 80th percentile of the sample mean. Well, 80th percentile, which is 80% to the left. And if it's 80% to the left, I know that I need to use the inverse norm, which is inverse norm is 0.80. The mean is 514, and the standard deviation is the adjusted standard deviation, which is 118 divided by square root of 65. And again, if you plug this thing in, your calculator should give you 526.3. Meaning if you score 526.3 on the math SAT, you are the 80th percentile based on this information, okay? So question with this three here. Would it be unusual if a sample mean greater than 550, which is, again, looking at this thing here, how do we know if if it's unusual or not. Remember, your cutoff point is 0.05. So basically, they just ask you find the probability to the right of 550, and if that probability or if that percentage is less than 0.05, we say unusual. If it's more than 0.05, then it's not unusual. So looking at this thing here is basically tell you that find the normal CDF of 550 and some bigger value because again of the right hand side. So make sure to determine left hand side, we start with a small number, negative small number to that endpoint. Right hand side, we start with the endpoint, go up to the big number. And then if you do this thing here, you will have 0.007, which is unusual, right? Yes, it's unusual because 0.007 is less than 0.05, okay? Now, I will give you guys a cliffhanger and for E, can you tell whether it would be unusual for the individual, for an individual to get a score greater than this? So one thing is the difference between this problem and A, B, C, and D is A, B, C, and D. If you look at the question, they all talking about a sample mean, a sample, a sample, a sample, a sample, right? Meaning we deal with a sample. This thing here, we are not dealing with a sample, ladies and gentlemen. If we are not dealing with a sample, we are back in 6.1, which is looking at this thing here to calculate this item. We do not do the adjusted sample standard deviation because we are not working with a sample. We are working with the population, which is again, because we work with the population will be one, standard deviation will be 118. So, you know, this two problem, the difference between these two problems is E, we are not working with a sample. We work with the individual, which is the individual, we compare that to the population, which is we don't need to do any adjustment. And therefore, the probability of this thing here is 0.38, which is this thing is bigger than 0.5. So this thing is not unusual. No, it's not unusual. Okay. So again, that's why, like I say, I will give you guys this cliffhanger right here. Don't worry about E for now. Monday, we'll